right. Welcome back to the education track here at PyCon AU 2018. We are joined by the fantastic Brad Nielsen, who is going to talk to us about object-oriented programming, moving from GameMaker to Pygame. Brad is currently the Digital Technologies Coordinator at Marist College in Ashgrove. He's taught IT for several years, teaching Python specifically for 5 years. And before that, he worked for several years as an e-learning specialist for various companies and organizations. Brad, thank you very much.
All right. Hi, everyone. Okay, so yes, I've been teaching IT for the last 5 years at a certain school. And in that time, we've gone purely Python. So I quickly made the decision that Python was a really good language for my students to learn. But the difficulty and the challenges were, how do I actually develop that progression into students learning Python? And there's two main challenges that I've identified. One is transitioning students from visual block coding into text-based coding. And the second challenge, and in some ways it's a challenge that I've chosen for myself, is how do I actually teach my students object-oriented programming? There's actually a lot of debate about this. Certainly in Queensland, where I'm from, the Queensland government's just produced the new IT syllabus, and it begins next year. And that IT syllabus makes no mention of object-oriented programming. It had specifically mentioned it, and then a lot of people complained, and every reference to OOP was actually removed from the syllabus. It's not that I can't teach it, I'm still able to teach it, but I think for a lot of educators, it scared them. And to be fair, object-oriented programming does present massive challenges in terms of teaching. From my point of view, though, it's really important. It's important because it's what's used in industry. It leads to better programming, more efficient programming, and it also allows students to be able to effectively use the Python libraries that are out there to basically create a myriad of exciting and interesting applications. And one of the best things about my job is I get to play around with all these different Python libraries and different gadgets that might run Python. And it's super interesting for me, but it's also super interesting for the kids. But on some level, it still requires students to understand a lot about object-oriented programming, because objects give context to what they're learning. I mean, even teaching kids Python Turtle, for example, Python Turtle has an object in it. So rather than students actually just making blind calls to the library, I would actually have them understand what they're doing and then being able to create their own objects by the end of year 12. But OOP is difficult to understand. And just before I go on, one of the biggest issues is it's abstract. When we talk about objects, it's hard to teach students that a piece of code can actually have properties and behaviors. If you haven't had much to do with object-oriented programming, I'm just going to go quickly through it now, just to give context to what I'm saying. But for me, I believe teaching students object-oriented programming gives them the context to further their studies as well. So if you haven't used, well, actually, to be honest, you've all probably used objects. Python is very much an object-oriented programming language. Something as simple as a string is actually an object. An object is a complex data type, and a string contains within it a list of characters, and it also contains functions that can be used to manipulate those characters. So when we talk about objects, it's about using that data type effectively. We don't actually need to see what's inside it to be able to use it. The foundation of an object is something known as a class, and in essence, a class is a blueprint to creating that object. So while we can use someone else's class class to create objects, we can also define our own classes and define our own objects. So we're defining our own advanced, complex data structures. When we actually create the object, it takes up memory, and then it becomes an instance. So the class is a blueprint for an object. We can make many of those objects. When we create them, it's known as instantiation. We're actually creating an instance of that object. Some of these terms are important because when I talk later about GameMaker and Pygame, you'll actually find that there's actually a lot of similarity between what they're doing, and there's a lot of symmetry between what they're doing, and they're actually explicitly teaching students those types of object-oriented principles. Just going back to that there, the example that I've got on the screen, there's a bicycle object. So let's just say you're creating an object to represent a bicycle. You can see that the class contains functions, functions to do with the object, and it also contains its attributes. So an object has, and this is something that I teach my students explicitly, an object has properties or attributes, and it has behaviors or functions. The benefits of doing it, and this is why industry uses object-oriented programming. You've got abstraction, so we're simplifying the code in many ways. We're focusing on what an object does as opposed to what's actually inside it. So in some ways, when we actually use objects, we're actually creating an interface for our code. Someone doesn't have to read all the specific code that underlies it to be able to use it. And that actually is part of what makes it difficult for students to understand. And then there's encapsulation. We're actually wrapping up our variables and our functions inside this self-contained unit that we can use lots of times. And then finally, there's inheritance and polymorphism, which is, in essence, us actually being able to adapt someone else's object. So you can have a parent object, and then you have a child object where it inherits all the code, and then you can actually do something else with it. And the example of polymorphism there, you've got, if you had a piece of code that represents a bike, you could actually have a mountain bike, a racing bike, a tandem bike. And those bikes inherit the code from the code for a bicycle. If you're sitting there confused at the moment, it will make more sense when we talk about games. And this is primarily what my speech is about, is I'm actually using games to teach objects. And I make no apology for that. I have a lot of teachers at school make fun of me because I'm sitting at my computer, and a lot of times I'm either making a game or I'm actually playing some other student's game. So they think I'm just sitting at my desk playing games all day long. But I make no apology for it, because allowing students to use games and make games actually is a really, really good way of teaching object-oriented programming. And there's actually a lot of research and studies that actually back that up. So if teaching objects can be difficult, at least with teaching using games, you're providing a context that will motivate them to try to struggle through that, and there is an increased cognitive load. And the other thing is, it's actually an intuitive way to show students that a piece of code is an object, because the thing about games is they actually simulate real-world behavior, or a lot of games do. And an example of that would be Pac-Man. So if you think about the game Pac-Man, and you think about what types of objects might exist, you would actually have the Pac-Man, you'd have the ghost, and you'd have the Pac-dol. So each one of those elements of the game could easily be represented by an object in Python. And you can see how an object itself has properties and it has behaviors. So I'm constantly drumming this into my students. Okay, so what is GameMaker? GameMaker is a simple drag and drop type gaming environment for 2D games, but it allows students to create really, really effective, really nice, visually attractive games that excite them. And probably the best thing about it is it's actually a really good vehicle for teaching object-oriented programming. And when I talk about Pygame, it actually makes that, it teaches students the stuff they need to be able to use Pygame effectively. So as I said in the beginning of my speech, one of the things I need to do is transition students from drag and drop and visual block coding to text-based coding. So in terms of GameMaker, if I get the students to do GameMaker in year 9, they're starting to make that transition. And then when it gets to year 10 and year 11, year 12, I'm starting to look at Pygame. And the stuff they learn in GameMaker transfers across. So I'm just going to briefly show you GameMaker. By the way, you can download a trial version of GameMaker. So that's generally what I get my students to do. But you can also get a classroom license. The classroom license will cost you money, but it allows them to publish, whereas the actual trial version will allow them to create a game. It might be a little bit limited in its functionality, but I find it's simple enough for me and my courses. So I'm all about saving money. But I mean, the classroom license would be quite effective if you've got enough students using it in your school. For myself, I might have maybe 60 students in a year. So I don't know, it's a bit debatable about the costs. Now, the interface of GameMaker is very much, it's got a lot more difficult over time, but it's very much explicit in terms of object-oriented programming. To give you an example, you'll notice, I don't know if you can see it from back there, but you'll actually notice that there is a tab there called Objects, and you can create an object. So in GameMaker, everything is an object, and those objects have properties and behaviors. So everything actually inherits their stuff from something called the game object. And the game object in GameMaker has an X and a Y position. It has a sprite, which is its image, and then it's actually got various functions that go along with that. So there's things like render and display and visibility and that kind of stuff. So here is an example of a spaceship object. And the thing about these objects is I can choose a sprite for it. So you load your images in. You've also got events, and GameMaker has a whole set of events that you can have, whether it's a key down or a key pressed or a mouse click, or even just it being created or destroyed. Everything's there. The functionality is already there for students to be able to use. Every object also allows you to create what's known as instance variables. So I can actually create variables inside the object. And when I refer to another object, I can actually find another object and find its instance variables, or I can call its instance functions. So the actual terminology relates straight across to object-oriented programming. So it's really good for building up that context. There's also a little tab here called parent. And if you use a parent, you're actually creating an object that inherits all the code from another object. So it's teaching them inheritance. In terms of the coding, you can see it's drag and drop. So for each of these events, I have code attached to it. So on the create event, I'm jumping to a point. On the step event, which is run every frame, I'm rotating based on where my mouse is. So if I actually play this game, by the way, it's not a completed game. I never actually give the kids, this is an example game, I never actually give them my fully functional game because I want them to improve upon it and then start creating their own. So occasionally I'm going to die because an alien's jumped straight on top of me. So it's not a fully finished game, but you can see the various objects that are there. And it's quite easy to create this kind of stuff using GameMaker. By the way, when I'm creating bullets there, the bullet is an object. And the object is, the bullets are multiple instances of that same object. So it's really about, when we define an object in GameMaker, you're creating a blueprint, and then you're actually creating something based on that blueprint. Okay, I'm going to move on. There's so much in GameMaker, you'd really have to try it out yourselves. However, one of the things I do during that unit is I actually show the students what's meant by a game loop. So I'm going to have to quickly jump through that. Because that's probably one of the most difficult things for students to understand when it comes to games, is the idea of a game loop. The game loop will run, it will basically clear the screen, go through the logic of each of those objects, and then it actually will render the next surface. So there's a frame there, and it's constantly going non-stop. So using GameMaker, I teach them about the game loop because it's actually going to come in handy when we start looking at Pygame. Just to jump out for a second, in terms of the sequence of teaching object-oriented programming, so in year 9, I teach GameMaker, and they're just starting to make that transition from drag and drop into proper coding. One of the things I haven't mentioned about GameMaker is you can actually put in some little scripts that are text-based, so you can kind of blend the visual drag and drop stuff with the text. Year 10, I'm actually teaching Python, and I start teaching them things like Python Turtle, tkinter. I use a lot of grok learning, microbit, and a few little robots that actually use Python libraries. And one of the things there is we use objects, but I don't teach the kids how to make their own objects. When it gets to Pygame, that's when I start teaching the students how to make their own objects. So Pygame is a Python library for 2D gaming. It's very much object-based. Objects actually inherit from something called a sprite class, and it has its own inbuilt kind of event handling. So I'm just going to jump out and show you Pygame. And I'm just going to show you just a quick demo. This here is just, again, I don't want to give students too much code because then they'll basically just take my game. So I show them a very simple game that they generally won't be happy with and they'll want to improve. But you can see here, in Pygame, you create a class which defines the game object, and it inherits from something called the sprite class. And then you actually define your functions and your variables. So in Python, you can define all your instance variables inside the init function. You can actually define it outside the init function too, but I find it easier to just show students how to initialize their variables this way. And then you have your functions like draw or set speed or update, where it will actually process the user's input. So this is actually a very, very simple class. And then the other part of Pygame is the game loop. And this is where the concepts and the principles that I've been showing students from GameMaker translate across. Because when you actually go into Pygame, you're creating yourself a game loop. And in that game loop, you're regulating the frame rate, you're clearing the screen, and then you're starting to do the logic. And it processes the events. And using those events, it then passes the necessary input to those objects. So you can see the symmetry between GameMaker and Pygame. So I'm not having to teach everything from start again. The students already know what an object is. They know it has properties. They know it has behaviors. They know about the game loop. Then I get to Pygame. I don't have to teach that stuff again. I can focus more upon actually how do you create an object in Python. Probably the only thing I find hard to explain to the students is why they have to keep referring to variables via the word self. But that's another story. But in terms of, I'll just run this code now. And like I said, it's a very, very simple game. But this one here is just basically a caveman running around trying to get steaks. I would have the sound on, but I just make a moo noise. So it's like a cow noise every time he collects a steak. And it's actually really, really annoying. But anyway, so you can see it's a very, very simple game. I give the kids this code because then I know they're going to adapt it. If I made a really good game, they might just come back and just change a little bit and give it back to me. But I know they're not going to enjoy this game too much, and they're going to come up with a better one. So I'll show you one of the games that a student has made. And this student was quite amazing. And I should mention they use Pygame in year 11. So by this stage, they know a lot about Python, but now they're starting to learn about objects. And so in terms of the code, there's you can just see the amount of code is amazing. He's even creating objects based on his own little maps. So, and in fact, the really fun thing about this game is, actually I should have the sound on because the music's actually really cool. But he actually makes objects during the game because you can actually destroy objects, make objects, etc., etc. So I really should have the game on for the music on for that. Right. So that shows you Pygame and that shows you GameMaker. There's too much in there for me to possibly cover everything. But I recommend it as a process of teaching students object-oriented programming because you get the context and it translates across, and that reduces the cognitive load. Right, any questions?
While you're answering questions, can you flip back to the slide that showed, about 3 slides ago, what you're doing each year level? That'd be awesome. That's it?
Yeah.
Fantastic. Yes, here we go.
That
Yeah.
Code Combat, what's that?
Oh, Code Combat. It's just it's actually a game that teaches Python. Actually, you can teach JavaScript with it too. It's actually, yeah, you'd have to see it. Just type in codecombat.org, I think. And it's literally a 2D game that teaches students, they have to solve puzzles using Python. So it's actually really, really, really simple. And it's actually it's the first introduction I give my students to Python programming. Yeah.
Yeah.
What about the kids in years 7 and 8?
Year 7 and 8. They're still doing a lot of block-based coding. So in year 7, they do Scratch. I've been playing around with a bit of Minecraft and MakeCode. So you can actually do Scratch with Minecraft now. Year 8s, they're using microbits, but they're still using block-based coding. But they start doing the code combat there. So that's when they're starting to just get the idea of text-based programming. And then year 9, they do it a little bit more. Code combat is just a really good thing to use when their students have finished everything, I found. So.
You mentioned that in your games, the caveman makes a really annoying moo.
Oh, it's just, yeah.
How do you find that sound, that making sound as part of the games is a motivating or demotivating factor?
Oh, definitely motivating, yeah. So, I mean, if I had the sound on, that snowman little game has really funky kind of arcade music to it. So, no, the students love putting sound in and special effects. And GameMaker allows you to have particle explosions as well. So, they love all that. The thing is, I don't want to do it for them. So, for me, I give them starter things that I'll hand to them, but I know they're going to do something wonderful with it. And normally I'll show them another student's work that has all that kind of stuff in it. Something for them to aspire to, yeah.
Hang on. Otherwise you're not on the recording.
Hi, with the interface, that came straight out of Pygame, didn't it? You didn't have to call up to Kinter to get the
No.
the interface.
No.
Yeah, thanks.
Yeah, it's Pygame is just a 2D gaming library. Yeah, it just comes up. Hard to explain actually. You'd have to, if I go to that code. Yeah, you have to bring your own images in. So here, one of the things I do get the students do is separate their objects normally into their own files as well. But it's pretty much you initialize the Pygame and you import the Pygame. By the way, that's the hardest thing I find students have to master is actually installing it. Installing Pygame is actually the hardest thing for them to do, especially the students who are using a MacBook, because we're a bring your own device school. So, and the MacBook just hates installing stuff. Yeah.
How much of the code would you typically give to the students? Like, what would you give them the class definitions, or how much would you be expecting them to edit it or create stuff from scratch themselves?
I give them the caveman, so they've got a caveman class there, and there's actually a steak class as well, and that's it. And I give them the main game loop. By the way, there's actually I don't know if it's, There's actually a really good website for this. There you go. Program arcade games using Python. Actually, no. Wait. I should actually... Maybe I'll include it later on. There's actually this really good sample website, and I point them there. It doesn't give them a full game, but it'll actually show them things like detecting a mouse click, or moving a sprite, or jumping, or that kind of stuff. So I think it's Python arcade games or something. Maybe it's got a different... Maybe this is it. I think it's just got a different interface to what I'm thinking. But anyway.
I might suggest that we, after the talk will be published on YouTube, and you can comment on the talk. So
yeah.
Look there for whether or not...
Yeah, actually, I should have included some links. I'm sorry. Yeah.
I had one more question about the scaffolding as well. So if you give them this, do you have... how do you set the students' expectations of what, in terms of assessment? I assume this is an assessable task.
Yes.
Of what makes a good game and the requirements.
Good question. I asked them for various things. So one, there has to be some monsters. Two, there has to be a score. Three, I wouldn't mind health. And one of the things I also asked them is for different game modes. One being invulnerability, because I don't last 2 seconds playing their games. A lot of their games, the kids have designed their games, they play them over and over again. They're just like fantastic, but they know what's happening. They know which monster's going to come out, they know how to beat their game, and then I play it, I die within 10 seconds, and they think I'm no good. But it's actually just, they have become expert players at their own game. So I ask them, and this is actually one of the ways I can work out who's going to get an A too, because programming a game mode is actually the most difficult thing, because the objects in your game, all of a sudden the behaviours have to change. So it's actually one of the ways I work out who's going to get an A is by the game modes they've put in. So they might have a power-up as well, like you discover something and you become super fast, or maybe you've got all the monsters start running away from you, just all that kind of stuff. The game modes is actually, and the power-ups is actually where the tricky kind of programming comes into it. So I put those very loose. I don't want to stifle creativity, so I just list different things that I want. But the type of game they choose, that's up to them. Yeah.
Fantastic. All right. Thank you very, very much.
Thank you, everyone.
I will give you a mug as well. More muggings. Here we go. Thank you very much. Genuine.